For this video, we'll be discussing deflections in beams or yung pag-change ng shape ng beam natin because of the application of loads. Deflection is often illustrated using the elastic curve. No? So, ito yung exaggerated bali na illustration ng ating deflection diagram. So, kung mapapansin nyo, merong changes nung or merong displacement. No? So, ito bali yung original line natin, original na position ng ating beam. Because of the application of loads, magiging ganito yung itsura niya. But in actual, hindi talaga magiging ganito yung curvature ng beam natin. No? So, ito ay ginagawa lang natin, ina-exage lang natin para mas ma-visualize natin yung movement or yung pag-change ng shape ng ating beam because of the application of your loads. Sa paggawa ng elastic curve, mas mainam na gumawa muna tayo ng moment diagram para mas ma-illustrate natin ng tama yung movement or yung displacement ng ating beam because of your loads. Ganito bali yung behavior ng beam natin pag merong negative at positive moments. Pag negative moment, ang effect niya sa beam natin ay concave downwards. Pag positive moment naman, nagiging concave upwards. Kaya lang, hindi lang ito yung tinitingnan natin sa paggawa ng elastic curve. Tinitingnan din natin yung effect ng supports. Napapansin nyo, zero yung displacement natin at the roller support and the pin support. At saka dito din sa fixed support natin. So walang displacement na nangyayari pag support. Kasi nga yung mga supports natin, nagre-resist sila ng forces. So ibig sabihin, nire-resist din nila yung displacement. Pero napansin nyo din na dito medyo flat yung line of line ng diagram natin. Ibig sabihin, pag fixed support, zero na yung displacement, zero din yung slope. So, yung displacement natin na y equal 0, yung slope natin na theta, 0 din. Pag dito naman, kung napansin nyo, merong slope yung, kunwari, itong line na to. So, meron siyang slope from the horizontal. So, pag roller or pin support, displacement lang yung 0. Pero meron tayong slope ng diagram. Pag fixed support naman, 0 yung slope, 0 din yung displacement. So, yun yung kaibahan bali nung supports natin. Ang tawag natin dun sa kanila ay boundary conditions. No? So, makatulong sa atin mamaya para makuha yung mga deflection natin or makuha yung displacement natin tsaka yung slope at certain points in our beam. The first method in solving for your slope and deflection is by integration or also known as the double integration method kasi dalawang beses tayo mag-i-integrate, no? First integration will give us dy over dx. So yung dy over dx natin is the slope of your deflection diagram or elastic curve. Second naman, pag second integrate natin, makukuha natin yung y or yung value ng displacement natin. So ito yung process ng ating double integration method. Una is gagawa tayo ng elastic curve or yung deflection diagram. Second is gagawa tayo ng moment function. So ito yun, no? And then the third is to integrate para makuha natin yung slope and displacement ng ating elastic curve. For this problem, we're given with the following data. So we have a cantilever beam here. Point A is a fixed support and then the overhang is point B. We're given with a triangularly shaped distributed load with the maximum load as 3 kip per foot. So this is a W14 by 30 steel beam. So the I is already given here as 291 inch 4. Then you have the modulus of elasticity for steel as 29 times 10 to the 3 KSI. So our required here is to determine the maximum displacement and the maximum slope in the beam. So as we stated earlier, our first step in determining the slope and deflection is to illustrate the elastic curve. So we know that at the fixed support we will have no displacement and no slope. So zero ang displacement and slope. So medyo flat yung elastic curve natin dito. And then we will have something like this. So the maximum displacement is the overhang. This is y max. Also the maximum slope will happen at this particular point. So dito makikita nyo, yung slope natin is 0. So, ganun yung slope natin, no? Ito. Tingnan. So, ang pinaka malaking slope natin ay mangyayari dito din sa point na to, no? Sa overhang. Dito sa overhang. At x equals 9 feet. So, bali, nag-change yung slope mo ng paganyan. Ito yung maximum na slope. So, ito yung maximum slope mo ngayon. This is your maximum slope. So, ang second na step is to derive an equation for the moment function as a function of the distance x. So, bago natin yan makuha, yung moment equation, kunin muna natin yung reaction at A. No? Yung RAY, and then you have the moment ng A. Diba kasi meron tayong dalawang forces na reaction dyan, tsaka isang moment. Wala naman tayong ibang forces na involved dito. We have summation of forces lang. Summation of forces along y equals 0, magiging RAY is just equal to 1/2 3 times 9. So RAY equals 4.5 times 3. We have 4.5 times 3. 13.5 kips. And then yung moment natin, summation of moment at A, for example, we have MA equals 3, 1/2 na naman, no? We have 1/2 3 times yung length na 9 times moment arm na, pag dito, ang resultant natin ay nasa 2/3 of the length. Pag dito naman, ito yung 1/3. Bali, ito yung 1/3. Ito naman yung 2/3. So, 2/3 of 9. So, moment A natin equals, ito cancel. Ito naman cancel. So, 9 times 9 is 81. Keep foot. So, meron na tayong moment ng A sa reaction. Meron tayong reaction at A na Y. Para makuha natin yung moment equation, kailangan lang natin na mag-cut ng section dito somewhere sa ating beam para makuha natin yung single na moment equation as a function of your distance x. Ngayon, kasi hindi naman uniform yung load natin, at saka hindi rin natin alam kung saan yung x natin na distance, hindi natin alam agad, no, kung ano yung height o ano yung load dito sa distance na ito, no? So, kailangan natin kunin yung W as a function of x din. So, meron tayong similar triangle na gagawin. This is 3, this is W, this one is x. Ito namang mas na distance is x. This is 9. This is x. So, merong 3/9. And then you have W over x. Tama ba? You have 3 divided by 9 tas W over x. So, W is just 1/3 x or x over 3. So, ito ay x over 3. So, as a function of x na siya na yung W. So, ang moment natin, equation for our moment is just equal to, ito, no, we have 13.5 dito. So, ang 13.5 ay papunta dito. So, you have 13.5 x. Ito naman ay minus, no? Minus, we have x over 3, or 1/2 muna. 1/2 base times height. 1/2 x over 3 times x. Tapos yung moment arm niya, syempre dito tayo nagmo-moment, no? So, moment arm niya is x over 3 din. So, bali, ito yung resultant ngayon ng ating triangular load. So, 1/2 na height times base. So, x over 3 times base. Diba? Triangular na area. 1/2 base times height times yung moment arm mo, which is equal to x over 3. So, again, pag triangular, Yung resultant ng triangle natin is ito ay 2/3 x. Ito naman ay x over 3. So 1/3, 2/3. Pag nasa mas mahabang height, x over 3, pag base mo naman dito sa 0, that's 2/3 x. So sa mga hindi natapos yung statics dyan, yan o yun, triangle. So ito yung resultant na triangular na load natin, 1/2 base times height times moment arm na x over 3. Tapos meron pa tayong isang moment na minus din kasi pareho sila ng direction dito. We have 81. Wala nang x kasi moment na to so wala nang moment arm. So simplify lang natin. M as a function of x equals 13.5 x minus magiging 1/2 or 3 times 3, that's 9 times 2, 18. 1 over 18 x cubed minus 81. Okay, so meron na tayong single moment equation para sa buong beam. Ang next natin gagawin is to integrate your EI. Ito d squared y over dx squared equals m as a function of x. Tapos for the second integration, meron tayong dy over dx equals yun integral ng mdx natin plus c. So dito makukuha na natin yung slope. At third naman, meron tayong y, double integral na ngayon ng mdx. Meron tayong ito c1 pa lang to dito, no? Meron tayong dalawang constant na, c1 plus c2. So ito yung unang gagawin natin, and then integrate natin para makuha to, and then integrate na naman ulit para makuha yung displacement. So diretsuhan na natin d squared y over dx squared equals yung equation natin kanina, which is 13.5x minus 1 over 18 x cubed minus 81. So integrate, and then you have to integrate din. Meron ka ng EI times dy over dx equals, so i-integrate lang natin to. We will have 6.75 x squared kasi x squared over 2. Tapos meron tayong 1 over 18 divided by 4. That's 0.01389. 0.01389 x to the 4. So we have minus 81 x plus c1. So meron tayong isang constant na c1. Pag i-integrate natin ulit to, magiging EI y equals 2.25 x cubed minus 0.002778 x to the 5th. So i-divide lang natin ng 5, no? 0.1389 divided by 5. Ito yan, no? 2.777 times 10 to the negative 3. Ito naman, i-divide natin ng 2. We will have 40.5x squared plus c1x plus c2. So yun yung equation natin for pangalawang integration. So ito na yung equation natin for slope. Ito naman yung equation natin for displacement. Given naman tayo ng E tsaka I, i-evaluate lang natin to yung distance na x na equals 9 feet. Kasi sabi natin kanina, dun yung maximum na slope and maximum displacement. Pero kailangan natin kunin muna yung C1 and C2. So paano ba makuha yung C1 and C2? That will be using our boundary conditions. So yung boundary conditions na na-mention natin kanina, yun yung gagamitin natin yung known facts na pag support mo ay pin roller, zero yung displacement. Pag support mo naman ay fixed, zero ang both displacement and yung slope. Dahil fixed yung support natin at A, which is x equals 0, pwede nating sabihin na at x equals 0, yung dy over dx natin or yung slope equals 0. Kasi nga, fixed support. So isa-substitute lang natin tong boundary conditions na to para sa equation natin dito. Makukuha na natin yung C1. So x equals 0, 0, 0, magiging C1 equals 0. Diba? Kasi 0, 0, 0, 0, C1 equals 0. Next na boundary condition natin para dito, at x equals 0, ang y mo din, or the displacement, is also 0. So, i-substitute lang natin tong x equals 0 and y equals 0 sa equation na to. You have 0, 0, 0, and this is 0. C2 will also become 0. So, wala na to, no? May eliminate na natin tong constants na to sa equation natin. So, masosolve na natin yung maximum na slope and maximum na displacement given that x equals 9 feet. Given tayo ng E tsaka I kanina, no, which is 29 times 10 to the 3 KSI times I, which is 291 inch 4. So we have EI equals 29 times 10 to the 3 29 times 10 to the 3 29 times 10 to the 3 times 291. You will have 8,439,000. Makakancel yung 2 inch, no? So KSI pa rin yung resulting na unit. So 8,439,000. So pwede nating i-solve actually, no? Diretso na nating i-solve. So kunin muna natin yung slope max at x equals 9 feet. Ito ay magiging 0. Ito naman ay magiging 0. This is 0. We will have 6.75 times 9 square minus 0.01 389 times 9 raised to the power 4 parentheses minus 81 times 9 divided by your 8,439,000. You will have negative 3 times 12 squared na conversion factor from feet to inches. So you will have negative 0.00466 radians. So radians yung resulting na unit, kasi unit negative, therefore in direction ni I. For the displacement naman, y max, substitute lang natin dito yung 9 feet. So we have 2.25 times 9 raised to the power of 3 minus 0.002778 times 9 raised to the power of 5 minus 40.5 times 9 squared times ulit conversion factor na cube by 8,439,000 of 0.369 inches, 0.369 inches downward. Kasi negative yung nakuha natin. Kung makikita nyo sa calculator, that's negative. Ibig sabihin, yung Y-max mo ay directed downward. Ito namang slope mo ay directed below. Parang ganito, no? Yan yung theta mo. Okay, so yun. Naman sa drawing kanina na kung ito yung beam natin, tapos ganito yung deflection. So downward yung deflection natin, y, kaya negative. Ang slope naman natin is negative slope kasi downward siya clockwise from the horizontal axis, no, or the x axis. So yun lang yun, no? Double integration. Sasagot pa tayo ng mga sample problems sa ibang video. So thank you again for listening at sana ay medyo hindi confusing yung solution natin.